Acceleration and U. At your age, it's natural to have questions about acceleration. Is my body accelerating? Are my friends? Are my friends accelerating more than I am? This video should help answer those questions. First off, let's begin by stating that acceleration is the rate that velocity changes over time. You may notice that your body is accelerating if there is an increased or decreased speed. Any change in speed equals an acceleration. Positive for increasing, negative for decreasing. Or any change in direction. Acceleration happens especially during non-equilibrium motion. That is, motion where there is a force that is greater in one direction than the other direction. To describe accelerated motion, let's take a look at a common everyday ostrich. The ostrich that has a positive velocity and zero acceleration will move off to the right, from left to right, in equal amounts each second. Each ostrich is equally spaced from the one before. The ostrich with a positive velocity and a positive acceleration will accelerate more, and each subsequent ostrich will be further away from the last one. Hey, get back here. An ostrich which has a positive velocity and a negative acceleration will decrease its speed, thus traveling less with each subsequent second. The formula for acceleration is A is equal to delta V over delta T, or V2 minus V1 over T2 minus T1. Note that this looks like the slope of a velocity versus time graph. Your teacher may also use Vf minus V0 over Tf minus T0. Let's use this to solve the problem now. Let's find the acceleration of an ostrich that begins at rest and speeds up to 15 meters per second after 5 seconds. First off, we want to recognize that we're solving for acceleration. We also want to write down our known variables. That would be that delta V is equal to 15 minus 0, since we began at rest, giving us a change in 15 meters per second for velocity. And delta T is going to be 5 seconds. The acceleration would then be delta V over delta T is 15 divided by 5 is 3 meters per second squared. That wasn't so bad. How much time is required for an ostrich moving at positive 12 meters per second to change direction and begin moving at negative 9 meters per second if it can accelerate at negative 1.5 meters per second squared? Well, this time we want to know what delta T is, and we're given delta V is the second velocity minus the first, negative 9 minus negative 12, which is negative 21 meters per second. And the acceleration is 1.5 meters per second squared. Rearranging our acceleration formula, we're going to multiply both sides by delta T, and then divide by acceleration to get delta T is equal to delta V over A. Pause and find the answer. Welcome back. You should have found that the answer is 14 seconds. If you didn't, check your figures, redo your ciphering, and try again. Now we want to take a look at how acceleration affects motion graphs. The first and most common motion graph is position as a function of time. You will remember that a constant velocity makes a constant slope on a velocity versus time graph. Now, if the slope of velocity versus time graph is equal to the, or slope of a position versus time graph is equal to the velocity, and an acceleration is a changing velocity, that means that we'll start to draw a line with a changing slope. that's going to look like a curve. When we have a positive velocity and a positive acceleration, it will curve upward as it moves upward. If the acceleration becomes negative, we get a frowny face. And when it becomes positive, we get a smiley face again. Positive accelerations make me happy, negative accelerations make me frown. On a velocity versus time graph, we will only ever have lines that are increasing, showing a positive acceleration, lines that are horizontal, showing zero acceleration or a constant speed, and lines that decrease, showing a negative acceleration. Our acceleration versus time graphs will only ever have horizontal lines, and these horizontal lines need not be connected. And zero would be the case where we're at constant speed. So remember, acceleration is a changing velocity, delta t v over delta t. It will cause curves on a position versus time graph. And to find the value for acceleration using a velocity versus time graph, we would find the slope. Thank you. Have a nice day.